some more questions out of 1.2. So we've got a couple more types to look at. Before break, we looked at the distance problems. We looked at one of those. We've got another one to look at. And we're going to look now at question 28. And this is on page 120. So page 120. We're going to look at question 28. So this one's a little bit different from the last one here. And what we're looking at in this one is we're looking at the speed of the wind. And the wind can either increase the speed or decrease the speed of an airplane, whether you're going with it or against the wind. So an airplane has a maximum speed that it can go. Now it might be able to go a little bit faster if the wind is helping it, and a little bit slower if the wind is pushing it back. So we're going to look at 28. So Anthony traveled against the wind in a small plane for 3 hours. The return trip with the wind took 2.8 hours. Find the speed of the wind to the nearest tenth if the speed of the airplane in still air is 180 miles an hour. So let's draw our vectors here. So we're going to be going to the destination, and then we're going to be coming back. So what do we know here? Well, these overlap each other, right? And they're the same because I'm going there and I'm coming back. So these should be equaling each other, shouldn't they? Okay, they should equal. Distances should be the same. Now, what do we know about the plane in still air? Well, the plane speed in still air is going to be 180, right? So that's the plane in still air. Now, what do we have when we work with this plane? We've got wind, and that wind is either going to add to it or take away from it. And so here's the wind here, okay, and it's going in this direction. And it says Anthony traveled against the wind. So this first one, the wind is going to push it back. What we don't know is we know the speed of the airplane, right? What about the speed of the wind? Does it tell us the speed of the wind? No. So let's call that then x. Because we don't know the speed of the wind, so we're going to use an x to represent that. Now, if I'm traveling against the wind, meaning that wind is going to push it back. If I'm traveling against the wind, then my time is 3 hours to get to my destination. Now, what about the rate? How fast am I traveling here? Well, my rate of speed is the airplane speed of 180. And then what's happening with the wind? Well, the wind is going to push it back, so it's going to be minus, right? Is everyone okay with that? One's plus, one's minus. So look at the direction of the wind. This is going into the wind, this is flying against it, so it's going to be a minus here. So this is my airplane speed. Wind is unknown, so we use an x there. And we know the time that it takes is 3. Now, what about with the wind? When I look at it with the wind, it takes me less time, so it takes me 2.8 hours. And my rate of speed is going to be 180 plus x, isn't it? Now, what do we know? We already talked about the fact that these should be equal, shouldn't they? Right? They should be the same. So now let's try to build our equation. They should equal each other. our distance formula is your distance is going to equal your rate of speed times your time. And when we travel against the wind, that is going to be rate times time. So that's going to be 3 times 180 minus x. Those two just get multiplied together. And when we travel with the wind, these get multiplied together, and that is 2.8 times 180 plus x. Is everyone okay with how I got that set up? So all of these, mixture, investment, and distance, these just get multiplied together. Now we can distribute that 3 through, and also distribute that 2.8 through. So when we distribute that 3 through, we've got 3 times 180, and that's 540, minus 3x. On the other side, we've got 2.8 times 180, that's 504, plus 2.8x there. Okay, so we just distributed through. Now we're going to move these around, and we're going to solve. So let's go ahead and move that 2.8 over with subtraction. And move that 540 over as well. And now it looks like we've got a minus 5.8. So it's going to be minus 5.8x there on the left. And on the right side, we've got 504 minus 540. And that's going to be a minus 36. Divide by the minus 5.8. And negative divided by negative, that makes that a positive. And 36 divided by 5.8. Let's do this in our calculator here. We've got 36 divided by 5.8. We know negative divided by negative makes it positive. So I don't even have to put the negatives in. Now, how far do we need to round? It says find the speed of the wind to the nearest tenth of a unit. So it's going to be nearest tenth. That would then be 6.2. And that is going to be in miles per hour. So the answer to this question is that wind speed is now 6.2 miles per hour. Okay, we've got 2 more types of questions left to look at. We're going to look now at mixture next, and then investment at the end. So let's go ahead now and look at some mixture questions. And on these mixture questions, we're going to be mixing chemicals together. And we're going to have to draw a diagram. And on the mixture ones, they always add together. So I want to make it a little bit easier. We don't have to worry about addition, subtraction, or equals. These always add together. We're going to do 2 mixtures, and we're going to do 2 investments. Question 31. And this is on page 121. We're going to look at question 31. Aaron wishes to strengthen a mixture from 10% to 30%. How much pure alcohol? Now, pure means 100%. So how much pure alcohol should be added to 7 liters of the 10% solution? So first thing I want to do is I want to draw my boxes. And these boxes are going to represent the different containers. So this is the way I do these. And I think it's about the easiest way to do them. I want 3 boxes, and these boxes are going to mix together. So we've got box 1 plus box 2 equals box 3. Each of these have an amount and a rate. And this is going to be very, very similar to the distance ones. Instead of a rate and a time, we have an amount and a percentage rate. So let's think about what we have. So he wishes to strengthen a mixture from 10% alcohol to 30. So box number 1 is where I'm going to start, and box number 3 is where I end up at. So what do I start with here? Well, we start with, percentage-wise, we start with a 10% solution. And we want to end up with a 30%. And in the middle, we're going to add in the pure. And we talk about pure. Pure is 100%. So these are our percentages. We did our percentages. We went ahead and labeled. Start with 10%, strengthen it up with pure to get 30%. What do we know that we have? It says how much pure needs to be added to 7 liters of a 10% solution. So on the 10%, we know we have 7 liters. So that's going here. So the 7 goes with the 10%. We don't know how much pure we have, and that's going to be our unknown. And now these add across because 1 plus 2 is 3. So these add across, and that gives you 7 plus x there. Now we've got it, and now we'll be able to quickly and easily solve this out. We're looking for our pure, and pure is the amount times the percentage rate. So the amount times the percentage rate is going to give you the pure. And just like we did with the distances, they just multiply together. So let's look at our first one, amount times rate. So that's 7 times 0.1. Second one, unknown amount x, percentage rate is 100%. 100% as a decimal is 1. And that is since 100% is 1. Okay, just remember that. 100% is 1, so that makes that the 1 there. And 1 plus 2 equals 3, so that's over here. And what's on the right-hand side? Well, that's 0.3. And what's it going to get multiplied by? 7 plus the x there. Now we have something that we can work with. So I'm going to go ahead and multiply here, and I'm going to distribute through the 0.3. So let's rewrite what we've got. 7 times 0.1, that's 0.7, that's that right there. 1 times anything is just itself, so that's just a single x. On the right-hand side, we distribute through, so multiply. So 7 times 0.3, that should be 2.1, I believe. Yep, and it is, right? 2.1 there. So that goes here. 2.1 plus 0.3x. Now we can solve it. Here's where students make a mistake. Whenever we work with decimals, let's put a 1 right here. That way we remember that it is 1x. That way when we move the decimals over, we don't make a mistake. I'm going to move the 0.3x over. And I'm going to subtract off that 0.7 as well. Now, be careful with our decimals. 1. So 1.0 minus 0.3. When I subtract those, that comes out to be a positive 0.7x. 2.1 minus 0.7. That should come out to be a 1.4, I believe. Okay, because those can cancel here, those can cancel there. Now we simply divide by that 0.7, and that gives me then x equaling now 2. And let's look at our units. Our units in this case are in terms of liters, so my answer would be 2 liters. I want to make sure we at least do one, hopefully 2 of the investment problems. So we only did one of the mixture ones. If we have time, we'll do another one. But let's make sure we do at least one of the investment ones. So let's look now at how about question 38? This is an investment one. And investment and mixture ones questions are very, very similar. There's not much difference at all. So we're going to look at 38. And then if we have time, we'll do 39. So 38. A church building fund has invested some money in 2 ways. Part at 3%. 4 times as much at 2.75%. Find the amount invested at each rate if the total annual income from the interest is $2,800. We're going to set it up the same way that we did the mixture questions, except instead of using containers with numbers, we're going to use dollar signs because we're working with money. And this, by the way, is on page 121. And we're going to be looking at 38. And you can label them 1 and 2 if you want. Each of these is going to have an amount, again, and a percentage rate. So it's basically the same as what we did for the mixture questions, except we're working with money. So question 38. A church building fund has invested some money in 2 ways. Part of the money at 3%. So my rate is going to be 3%. Now, do we know how much money went into that 3% account? Does it specifically tell us? No. So we don't know, so we're going to use an X to represent that. What about the next account? Well, for the next account, 4 times as much at 2.75. So 2.75%, 4 times as much, that would make it 4x. These add across to give you a total amount of 5x. Now, here's sometimes where students make a mistake. We have to remember the difference between the amount of money in the account and the interest that I earn on that account. So whenever I get a bank statement, that bank statement has 3 major items on it. How much money I've got. So it might be like, let's say, $10,000. So let's say I've got an account. It has $10,000. That would be your amount. Now, maybe you made $50 in interest. Okay? That $50 is not the amount. That is your interest. And it might say your interest rate is maybe 1%. So you have an amount of money. That's how much total that you have. Not the same as the interest. how much money you made, the interest that you earned, that's your second component, and the interest rate that it pays out. So those are the three parts to it. When we build our equation, we look at the interest. So instead of the pure, we just change the wording to interest. And the interest is the amount times the percentage rate. Let's look at our first one. What's in our first one? Well, these get multiplied together. Now make sure that you make the interest rates a decimal. So don't use the percentage. Make that 3% a decimal. So for the first one, that's these two put together. So that's 0.03x. Second one, because these always add. Second one is going to be 0.0275 times your 4x. And this is the total interest, not the amount, the total interest. And this comes from the problem. And what is our total interest from this question, this problem? We made a total of $2,800. So that is going here. Now we should be able to solve this equation and then get our answer. Now our answer is going to be both of these funds. So we're going to have two answers. So let's go ahead and combine and simplify. So that's 0.03x plus, I'm going to multiply those together. So multiplying 4 times 0.275, that comes out to be 0.11x there. That equals 2,800. We're going to add those together, and that gives me 0.14x equals 2,800. We're going to divide by a 0.14. And that leaves me now with x equaling 2,800 divided by 0.14. That gives me now $20,000. That is not my total answer. It's not your final answer. It's part of it. Only part of the answer. So that's only going to be part of the answer. How do we get the entire answer? What we want for our entire answer is we want to know how much is in both funds. Now, for the first fund, fund number 1, the amount is X, so my first fund is going to be that $20,000. So my first fund, okay, its amount was X, so that's going to be $20,000. And I want to label that. That first one was at 3%, so we got $20,000 at 3%. That's our first one. What about the second one? Well, the second one, the amount, if you go back and look, the amount of the second one is 4x. So that would be 4 times your 20,000. And that gives you then your 80,000. And that is going to be at now 2.75%. Okay, so that's what we wanted. So we've got $20,000 at 3%, and we've got $80,000 at 2.75. So these are our answers. And you want to label them with the percentages. That way you don't accidentally get them mixed up. How do we check? Just if you wanted to check, here's how you could quickly check. Let's say I want to make sure that what I'm doing is correct. How can you check this? Well, you can check them by multiplying. So we can check by taking that 20,000 times 0.03 and 20,000 times 0.03 comes out to be 600. And then we can take our 80,000 times 0.0275, and that comes out to be 2,200. And when I add them together, see, I get 2,800, and that's the same as the total interest. So that's how you can go through and check one of those. If you want to check it, make sure it works out for us. You just multiply the amount times the percentage rate, add them together, and that should give you your total. So that's going to finish up our lecture for today. And so let's talk about our homework for next week.
Is it next week or Wednesday?
Oh, sorry, Wednesday. I'm so used to meeting only once a week, but in the summer we meet twice a week, so we'll be meeting on Wednesday. So this is your homework for Wednesday. We've got 1.1. You should be able to do them all. And 1.2. You should be able to do them all. Now, if you have trouble on some of the ones out of 1.2, ask me next week. I always spend about the first hour going over questions, and I will set them up. I won't work them out completely, but I'll make sure that we all know how to set these up. That's always the hard part. So if you have questions out of 1.2 next week, ask me. I'm not going to work them out completely, but I will set them up and get you to that equation. Okay, so I will see everyone then on Wednesday.